This is questions 1, 3, 4 and 10 in exercise 8.3 in Newton Size Project Maths 3a. We've defined d2y dx squared for the first three questions here. So d2y dx squared is the second derivative. If we're trying to explain what that was, if the first derivative is the rate of change on a function, the second derivative is the rate of change of the rate of change. To put that in more simple terms, if you think about the rate of change of position over time is speed, how much distance we've traveled over a given amount of time. But our rate of change on speed is how fast our speed or how slow our speed changes, which would be acceleration. But that's in more practical terms. For the moment, we're just looking at the actual rule that's applied to it. So in question 1, we're given y is equal to 4x cubed plus 6x squared. So first of all, we're going to find dy dx. And that's going to be equal to 12x squared plus 12x. And that's because in order to differentiate each term, we multiply the power by the coefficient, and then we reduce the power on x by 1. So 3 by 4 is 12, and we reduce 3 down, and we get 2. And for the second one, it's 2 times 6, which is 12, and we reduce the power down to 1. But anything to the power of 1 is just itself. We didn't need to write in our power of 1. And now we're going to get the second derivative, which is going to be based off our first derivative. So d2y dx squared. So this time around it's 2 times 12, which is 24. And then we reduce our power down by 1. And for the other one, it's 1 times 12, which is 12. And reduce our power down, it goes down from 1 to 0. But anything to the power of 0 is just 1. So this here is our second derivative of that function y, 24x plus 12. Let's look at another example of that with question 3. So we're going to do the same process again. We find our first derivative, our dy dx. So 2 times 2 is 4. And then we reduce our power down to the power of 1. And with our constant here, minus 3, there is no derivative of a constant. So our derivative for this function is so far is just 4x. And then to get our second derivative, it's going to be 1 times 4, which is 4, and then we reduce our power down, but it's going to be x to the power of 0, which is just equal to 1. So 4 is our second derivative of this function. And then we look at question 4, where we have dy dx. So there's no when we derive 7, we get 0 because there's no rate of change on that. And then from minus 3x, we're just going to get minus 3 when we differentiate it. Which means that our d2y dx squared is just going to be equal to 0, which is what we get when we differentiate minus 3. So that's questions 1, 3 and 4. Now let's take a look at question 10. Now question 10 asks us to get the second derivative in a slightly different way than the first few did. It uses this notation which you can see here in the second part of the question, which is the f, and there's 2 dashes. So the first dash that we see in part 1, that's just the first derivative, and the second dash is just the second derivative. So we've got our function f of x. We're going to get our first derivative, the f dash of x, and that's going to be equal to minus 2 plus 3x squared. And then we're going to get our second derivative from that, which is going to be equal to 6x, like that. And now for part 1, where we're asked to get f dash of minus 5, we're just substituting minus 5 into the f dash function in place of x. So it's going to be equal to minus 2 plus 3 times minus 5 squared. Well, minus 5 squared is 25. So we've got minus 2 plus 3 times 25, which is just going to be equal to minus 2 plus 75, which is equal to 73. And then for part 2, we're going to substitute minus 5 into the second derivative. So we're going to get 6 times minus 5 is equal to minus 30, like that. And that is that.